to the bunch of you.
This meeting is being recorded.
Basically introducing to the bunch of you about blockchain. So there are a few major topics that we'll cover today. Basically, we'll introduce what is blockchain, and then we'll touch about proof of work and proof of stake. Some of you may have heard of it. Some of you will only hear of it the first time later. We'll talk a bit about smart contract as well, and then we'll introduce you to Tezos. So if you're not familiar with Tezos, just a brief TLDR, Tezos is basically a blockchain similar to like Ethereum, Binance, Cardano, and all the top few coins that you see on cryptocurrency charts. And then afterwards, Brian will take over and he'll cover some aspects of scalability of blockchain. He'll talk a bit about decentralized finance, and then we'll wrap it up with like an introduction to NFTs, what they are, and some of their new use cases. Okay, so if everyone can see my slide, right, I'll just jump off to the first question, right? So the first question is, what is blockchain? So fundamentally, a blockchain is a data structure that is behind Bitcoin. You can think of blockchain as a list of records, right? And each of them are called blocks that are chained together. Therefore, the name coming out as blockchain. So it's basically a digital ledger that keeps track of data on the network, whether is it transaction data, whether is it metadata transactions as well. Okay, and so basically you can think of in each block, right, that is in the blockchain, it stores a few key things. The first one is that it stores a batch of valid transactions. So these transactions can be anything like me transferring Brian 1 Bitcoin or vice versa, right, or any other of the currencies within the blockchain. It also contains a hash of the block. So when I say hash of the blocks, right, there's a lot of details that we can jump into. But for the purpose of today, you can just think of hash of the block as a unique hexadecimal number that basically encodes the data of the block. So whatever you change inside the block, you will basically change the hash of the block. Okay, and of course, it will contain the hash of the previous block. So that is why you chain them together. And that is also why they say that any block that is up on the blockchain, right, you can't really change it because it contains, for example, like block 2 contains information about block 1, and block 1 contains information about Genesis block. So you can imagine like from all the blocks, right, at like 100, basically it's all chained together. So you can't just change one of it and expect your block to be valid because it will throw off an error. Okay, so the whole idea behind blockchain is to solve the Byzantine generals problem. So this is a bit more technical, and this is where we talk about consensus mechanism. So just to introduce the Byzantine's general problem, I will show this video here, which will give you a good grasp of what it is. Let me know if you can hear can you guys hear the sound? Right, is the sound okay?
Yep, the sound is fine.
I'm going to explain it by using an ancient problem that Bitcoin claims to have solved. It's called the Byzantine generals problem, and until now, it's been unsolvable. The problem goes like this. How do you make absolutely sure that multiple entities which are separated by distance are in absolute full agreement before an action is taken? In other words, how can individual parties find a way to guarantee full consensus? Here's the example. Imagine that you are a general in the Byzantine army and you're planning to attack an enemy city. You have the city surrounded by several battalions, each of them camped several miles from the other, and each of them led by another general. A coordinated attack on the city from all sides at the same time will be successful, but an uncoordinated attack will likely end in defeat. You have decided to attack at dawn, but you have no walkie-talkies or cell phones, and signals from flags, torches, or smoke could be seen by the enemy. How do you make sure with absolute certainty that all of the other generals reach consensus and all attack together at dawn? You could send messengers on horseback, but what if one of them is captured or killed before delivering the message? You would need to have a reply from each of your generals confirming that they have received your message, which means that they would have to send messengers to you on horseback, but what if they are captured or killed? What if a messenger is captured by the enemy and an imposter messenger with a fake reply is sent back to you? And how do the other generals know that the messages that they received from you are genuine and haven't been intercepted and altered by the enemy? Worse yet, what if some of the other generals are traitors and they send messages back to you confirming that they will attack at dawn when their true intention is to retreat? How can you ever be absolutely certain that all of your battalions will reach consensus and attack simultaneously? Like I said, this problem has remained unsolved for thousands of years, and at its core, it's all about individual parties being able to trust each other directly, no strings attached. Bitcoin claims to have conquered this problem. Now imagine that the battalions are actually computers on a network, and that the generals are copies of a computer program running a ledger. A ledger that, via some very complex math, records transactions and events in the exact order that they happened. The key here is that all of these ledgers are exactly the same for everyone. As soon as a change is made on one copy of a ledger, if it is proven to be true by the math, all other copies of the ledger are updated to match. What we have here is a distributed ledger that is also always in consensus. This is one of the first things to understand about Bitcoin. It is the first full consensus distributed ledger mankind has ever seen. This network can be expanded across the entire planet. It means that individual parties on opposite sides of the world can come to consensus on an event without requiring any third party as an intermediary for trust. Whether it's an order from a general to his troops or an order from you for a pizza, a distributed ledger confirms via math whether an event is true and records it permanently. Bitcoin, the first full consensus distributed ledger, is a trust machine.
Okay, so basically, right, to wrap it up quickly basically sum up what the video was about, the Byzantine generals problem is about the issue of having a decentralized system, which also means multiple computers, or we call them nodes, right, all across the world, to be able to come to consensus on what is true and what is not. So, for example, if I send Brian 1 Bitcoin, how can we be sure that this happened, right? And how can we be sure that all these nodes around the world stores the same information that I've transferred in 1 Bitcoin? So that's basically the whole Byzantine general problem, and that is where consensus mechanisms come in. So we need some sort of system for everyone to agree on the fact that a certain event has happened and a certain event is valid. Right. So of course, if you look at the last point on the slides, all these issues can be solved if we have a centralized system. In this case, you can think about it as your banks, right? Because when you have a centralized system, the banks will be able to confirm with you that, oh yes, I did transfer Brian $10, right? Or your PayLah or your PayNow. It works that way through a centralized system. Okay, but essentially, blockchain is about decentralization. And the whole idea of centralized system is bad because it makes your system vulnerable to corruption by a certain central authority or a certain central entity. So that's where we go on to consensus mechanism, right? Which is the thing that powers how you can run decentralization or how a blockchain can even exist in the first place. And the most major one is proof of work, which is the underlying consensus mechanism for Bitcoin. So proof of work, in short, is a consensus mechanism that requires members to expend computer resource in solving a mathematical puzzle. And this process is also basically called mining. So if you all heard of how in China, there's a lot of like Bitcoin mining rigs and stuff, and why they are packing so much GPU and graphics resources into their factories, because they are all competing against each other to be the first person to solve this published mathematical puzzle for the block, right? So imagine I kind of release like a quiz questions at 12 a.m. tonight, and I say the first one who solves it will be able to get like $100. So you can imagine like 1 million of computers out there competing with each other, trying to solve this in order to get the reward, which is the Bitcoin rewards. Okay, so instead of reading like the worldly stuff on the right side, we can run through it using we'll use a diagram to explain it. Okay, so on the left, you have a proposed block, right? So just now we talk about what is inside a block. So what we do is that we combine the hash, right? We combine and then we combine it with the nonce. A nonce basically is just a random arbitrary integer that you can only use once to identify a block. And then at the bottom, right, you will see the previous block header. So this is the part where we talk about taking information from the previous block to chain it together. Okay, so we take the proposed block, we hash it together with a random nonce and the previous block header. This gives us a random hash number, right? Think of it as your hash map. You put in a certain input and a specific unique output comes out. Then now we have to check if the hash value is less than the target value. So this target value is something that is set by the blockchain. What this means is that you can imagine if, let's say, I have 1 million numbers, right? And I say that your hash value has to be less than 10, that would mean the probability of someone combining and hashing a number and it appears to become less than 10, it's very low, right? So basically when the traffic on Bitcoin or any other blockchain is running on proof of work, is getting more and more congested, right? We will lower the target value. So when we lower the target value, it basically means that it's harder. When it gets congested, then we will increase the target value, right? So that more transactions can flow through, then vice versa. Okay, then basically once the first computer that gets a hash number and it's satisfied the target value, they basically solve the mathematical puzzle and get rewarded. So if it doesn't fall within the equality, right, it basically tries another nonce and then repeats and do the same thing in a for loop. So essentially that is what it is. And then we'll move on to proof of stake. So proof of stake is a little bit different from proof of work. Proof of stake basically says that the mining power, right, is proportionate to the coins that is held by the miner. So instead of like having people compete to solve the puzzle in a way, the proof of stake miner is limited to mining like a percentage of transactions that is reflective of their stakes. In another way, you can think about it, like this is how I explain in layman terms to people the difference between proof of stake and proof of work, right? So imagine at a 100-meter race, proof of work is basically asking all the runners that I have to run down the 100 meters, and only one guy is going to be the winner, and that one guy will take away the full rewards. In proof of stake, the difference is that based on how much the runners have staked, in a way, stake meaning how much they have like locked up in the blockchain, right? The amount of coins that they locked up in the blockchain, that's their chance of them getting selected to run down this 100-meter race in a way. So those people who basically are not selected, they don't have to run the race. And that's why it's a lot more energy efficient compared to proof of work. Also, anyway, I forgot to say, at any point if you have questions, right, just feel free to type in the chat. Then Brian will try to answer you. If not, if I notice the question, I will try to answer you as well. Yeah, so this is quite a chill session, right? Because we don't have a lot of participants. So feel free to ask us any questions. Yeah, so when we talk about blockchain, there's always the blockchain trilemma. And I believe like if you're a computer science student, you've probably heard of it before. There's a fine balance between decentralization, security, and scalability. So decentralization means that the system does not rely on like a central point of control. And being scalable basically means it can handle increasing growing amount of transactions. Okay, and being secure basically means it's able to defend itself from attacks, bugs, or other like unforeseen issues. So Bitcoin, right? Bitcoin is something that offers high level of decentralization, but yet the scalability is not there. So because if a transaction required multiple confirmations before reaching consensus, then it would technically take longer for them. So being secure, right? Bitcoin being secure means that it takes a longer time, right, to get everyone to agree that A transferred $100 to B, let's say. And because it takes a longer time, it becomes very less scalable. And then, of course, over the years, we have a lot of other blockchains coming up, trying and attempting to solve this trilemma, right? Like just last year alone with the NFT hype, Ethereum gas fees became so much because you can see that Ethereum don't fall on the scalable side of stuff. That is where you have sort of more centralized blockchain. They still call themselves decentralized, but more centralized blockchains like Solana coming up to sort of tell people, hey, you can launch NFT on my blockchain, right? Because we are way faster, we are way cheaper than Ethereum. But of course, no one actually points out that because they are more centralized, it's less decentralized and more dangerous. and then there were like several outages and stuff that happens. So in essence, that's the blockchain trilemma. And next, we'll briefly run through some of the proof of work attacks. So I will not go through very much in depth, but basically these are some of the common attacks that can exist on both consensus model. So for proof of work, the first one is a 51% attack. So you can imagine if a mining farm in China kind of obtains like 51% of the mining pool, right? He basically has majority control of what blocks can be validated, or rather he can create his own forced transactions and possibly make it a valid block on the network. So I can easily say that Brian owes me $1 million, and then I will use my 51% of my mining resources to get this on the blockchain, right? And now the blockchain records immutably that, yes, Brian owes me $1 million. So that's the 51% attack. The selfish attack is basically a group of miners where they hide their blocks, right, that they have generated from the main blockchain, and then they will time it together such that when they time it together and chain their blocks together, right, it overtakes like the other block. So in blockchain, we always see like the longest block is the correct block, right? So you can imagine it as like a fork. Basically, when you fork out A and B, right, and A is the correct block, and then B suddenly becomes longer than like A chain, right? B becomes the correct block, which may contain a lot of wrong transactions. So next, then we'll talk about proof of stake attacks. There's a few. So first one is nothing at stake. So for some of the prior proof of stake blockchains, the validators, when there are a lot of forks going on in the blockchain, right, that basically nothing is stopping a validator from attempting to validate the block on every of those chain, right? So that they basically can get more rewards. And that's something that has to be decentralized, right? The next one is the long range attack. This basically means that that if there's an attacker with at least 1%, right, of all the coins from the Genesis block, they will be able to easily produce a lot of blocks and create a longer blockchain that overtakes the shorter one in that way, which makes the correct blockchain die longer. Okay, then the last one that we have for proof of stake attack is stake grinding. Basically, basically these stickers, they go back a few blocks behind when they got chosen to validate the block, right? They go back and they try and figure out what is the algorithm behind the selection of these miners. And then they basically try and modify their block such that they have a higher chance of getting selected again. Okay, so basically that's just a very quick run through of proof of stake and proof of work. There's a lot more that you can read about from the internet. There's a lot more you can find out about different hacks that have or have not happened in the past. There are a few big ones. There are a few big loopholes that have been exploited by hackers in the past for different blockchains. So that is something interesting that you guys can go and read about. And then now we will talk about Tezos. So Tezos is basically a proof of stake blockchain. And the white paper was published in 2014 and we officially launched with our mainnet in September 17, 2018. So it's already a 3 to 4 years blockchain that has been running. So the Tezos Foundation is actually founded in Switzerland. And yeah, so that's the brief history of it. And there are 3 key features that we separate ourselves from other blockchains. So the first of all, just now, remember when we were talking about the forking of a blockchain, right? So for us, every time a blockchain wants to upgrade itself, it has to fork to another branch. For developers, you most probably know what it is. It's like your GitHub, right? When you're creating a new branch, it's the same way for a blockchain. The protocol that exists on the branch cannot be changed. The only way you can update is to create a new branch and work on the new branch. But on Tezos, what we have is a self-amending protocol, which allow us to basically upgrade our protocols on-chain without having to do any forking. There are a few bad things about doing forking in order to upgrade your protocol. And one of it is that you will segregate the community that you have, right? So you have like in the past, there are a few blockchains that have kind of did like this forking and then their community is left like separated. The second point we have is smart contract formal verification, which I will jump into in more in depth later on. And the third one is our liquid proof of stake consensus algorithm. which I'll also go into deeper following the next few slides. So the first one is on ecosystem governance voting grants. Basically, Tezos is a self-amending crypto ledger, which I explained earlier, and we are able to modify our protocol on-chain using an on-chain control mechanism. What this basically means is that having an on-chain protocol upgrade, right, it allows us to keep our community and also reduces the likelihood of all the hard forks and friction that will bring about a lot of discontent in the community. And it allows us to iteratively upgrade our protocol very swiftly. In fact, every 2 to 3 months, we have a protocol upgrade to improve our blockchain, whether is it transaction speed, whether is it gas fees, etc. And basically how it works is that every mechanism upgrade, right, goes through a total of 5 periods. Okay, I'll just touch and go this. So in the first period, people can propose what amendments they want to make to the current blockchain, right? So if they think that something is better than the other, they can propose it. And then they will have a vote on it where your bakers, in this case, which are your miners, people who are staking, right, they will be able to vote on which proposal they want. And then subsequently, we have the cooldown period, and then the promotion period is where we start to test each of these proposals on the test net. And then finally, we will have the adoption period where we officially upgrade all our miners onto the same protocol, the same upgraded protocol. So this entire process takes about 24 days for it to happen. And these are some of the history of the upgrades that we have. So as you can see, the latest one we have was just last December. It was the Hangzhou protocol. So each of them brings about a new bunch of fixes and upgrades. And of course, the next question for some of you, you'll ask, like, what is a fork, right? So there are 2 types of fork in blockchain. Basically, one is the soft fork and one is the hard fork. So in the soft fork, right, the new protocol, right, will be a subset of the old protocol, which means that the new protocol, right, that upgraded one, it's more restrictive. And that is why it's more restrictive. So that is why the new chain, right, can still be accepted by the old chain, right? So, and then for the hard fork, it's the other way around, where the new protocol is basically more relaxed than the old protocol. And that leaves the old protocol no longer compatible with the new protocol. And that is where you need everyone to sort of switch over from one chain, from the old chain to the new one. Yeah. And on Tezos, as you can see all the way on the right side, right, of the slide, we are a bit different. So our upgrades we do it on the same chain itself. That's why we call it on-chain governance. So we have all our nodes to upgrade on the same chain. And basically we avoid the issues of like soft fork and hard fork. Okay, so the next one is liquid proof of stake, which is the third feature that we were talking about for Tezos blockchain. So baking is essentially a term that we use in Tezos for staking. Basically it's the participation in forming blocks in the blockchain based on like proof of stake consensus algorithm. So this design basically allows users to delegate tokens to bakers without having to transfer ownership, right? And this is also where the term liquid comes from. Since no tokens are being locked up or anywhere, then the delegator will receive like a proportional amount of reward distributed to the bakers in the form of XTZ, which is our native token. Then the next question is like, what is delegation, right? So delegation, think about it as like passing your rights or passing your tokens. For example, if you hold some XTZ, right, you can pass it to someone else, which is the baker. And basically you don't have to set up the whole node, right, that you have used to stake and to bake the rewards. Someone else will be baking on your behalf while you get rewarded a percentage of what they have. So maybe an easy graph to see is this one over here. Okay, so imagine like the first guy has 7,000 XTZ. The second lady has 3,000 XTZ, right? And basically the guy who has 7,000 XTZ, he has the capacity to set up his own node. Basically, he wants to become a baker, but he's short of 3,000. For example, to become a baker, you need minimally 10,000 XTZ. So the lady will be able to delegate her 3000 XTZ to the guy on top who has 7000 XTZ, and he will run the baking node. So this is how all your bakers are being formed through delegation, or maybe, like for example, the third guy can own 10,000 on his own and become a rightful baker. And then in every validation of the block, right, we will randomly select a baker as well as 32 random endorsers. So the baker will basically bake the block, which also means validating the block, and he will be the one getting the rewards. And the other 32 random endorsers, their job is actually to verify that the block was baked correctly, which means the transactions and all the data inside is correct. And then the endorsers will basically get a smaller fixed reward while the baker gets a big reward. So this process goes on for each of the block that it's like uploaded onto the blockchain. Yeah. So because of this behavior, right, where there is no locking up, there is lesser incentive for someone to kind of game the system, to kind of cheat the system by submitting a fake block. Because first of all, like the person who are delegating, right, their tokens are not locked up with the baker. So it is easy for them to withdraw their tokens and sort of report on their baker who is validating like the wrong block. Yeah, so there's no consequence to it. So this is just a quick rundown. There's a lot of different forms of proof of stake that exist across different blockchains, and liquid proof of stake is one of them. You can see some of the other examples like the Cosmos net, the Hcash net. They all use different variations of proof of stake, which we will not run through today. We will just let you guys, basically just want to let you guys know that this exists. And so now that we have touched on what Tezos is as a blockchain and how we are different from other blockchains, we will go on to talk about smart contracts. So I'm sure most of you who have kind of learned about blockchain would have heard of the term smart contracts. Smart contracts, essentially, they are programs and basically pieces of code that exist on the blockchain. Think of it as like writing a set of rules, right? And then putting it on the blockchain so that when the condition satisfies the rules, right, you can sort of execute this program that is on the blockchain. Yeah. So in Tezos, our low-level language, which is like the lowest form, is called Nicholson. This is a low-level language. So on the right side, you can see some of the example code. So this is like very cheap, very in-depth low-level language that is statically typed. And this is also what allows formal verification to happen. So formal verification, you can basically think of it as like sort of a final layer of security for your smart contracts, right? To ensure at the low code level that 1 + 1 = 2, right? That 2 + 2 = 4. So because of this Nicholson language, we are able to perform formal verification to make sure that our smart contracts are correct before it goes on the blockchain. So basically lesser unforeseen errors will happen on the mainnet. And then we have two languages, higher level languages. One of them is Lego, and Lego is split into 3 of these different syntax that you can use. It depends on where you come from, right? You have Camel Lego, which is from an OCaml syntax. You have Reason Lego, which is more towards JavaScript-like syntax. And then you have Pascal Lego, which is more Haskell-inspired syntax. Yeah, so some of these you probably wouldn't have heard of it before. Most of you probably heard of like JavaScript before if you have like computing background. So like Reason Lego would be more comfortable in a way. Yeah, but don't worry, there's another higher level language, which is called Smartpipe. So Smartpipe is a high level library for writing smart contracts with Tezos using Python programming language. So this is basically a library that is built on top of Nicholson, and it allows you to swiftly compile code from Python into Nicholson language for you to deploy onto the blockchain. So these are the IDEs that you can see. They are integrated IDEs on the internet. From your browser, you can work on it. So on the left side, you have the Lego IDE, and on the right side, you have your Smartpipe IDE, which is also capable of compiling your code as well as deploying your code onto the blockchain. And the next thing that we'll touch on is token standards. So token standards, if you guys have heard of, in Ethereum, we have like ERC 721, we have ERC 20, right? So token standards are basically a set of functions or a set of rules that a smart contract must have for them to be sort of globally recognized as obeying a certain standard, right? So it's a bit cheap, but basically think about it as if you want to become a coin on Ethereum, you need to have a set of functionalities in your smart contract, right? So that all the Uniswap, your SushiSwap, your centralized exchanges and decentralized exchanges will be able to recognize and use your functions such as transfer, functions such as swap, right? So that all these functions must exist for you to become compliant. So on Tezos, we call it FA 1.2 and FA2. So FA 1.2 is basically your token. To put it simply, FA 1.2 handles your fungible tokens on the right side. So fungible tokens basically means that each of these tokens are equal to one another. One XTZ will be of equal value to another XTZ. And your FA2 contracts will handle most of your non-fungible tokens. Non-fungible tokens basically means the opposite, that each of them are unique. Right, so later on we'll touch more about NFTs, which are basically non-fungible tokens, and how people use it to tokenize art pieces and graphics and stuff like that. Yeah, so I've sort of covered this really. Fungible tokens, right? They are interchangeable, like your US dollars, like your one Bitcoin, your Ethereum. And then we have the token standard of FA 1.2. Okay, so instead of reading all this, I'll just jump to this slide. So you can see the one in bold, right? Transfer, approve, get balance, get allowance, get total supply. So basically, in essence, right, your contract, if you're trying to launch a coin on Tezos, your smart contract needs to have minimally these 5 functions that is according to FA 1.2 standard for it to be recognized and utilized as a token on Tezos blockchain. And then for non-fungible tokens as well, you guys have probably heard of it, NFTs. These are basically opposite and they cannot be replaced by another identical item. And in Tezos, we use FA2 standard to create non-fungible tokens. And similarly, we can look at this. We just need to make sure that they have 3 functions, or we call it entry points. We need to be able to transfer, get the balance of a certain wallet and how much NFTs the specific wallet address is holding, and also this function called update operators. Yeah, so this is a quick summary of FA 1.2, FA2, which are both on Tezos, compared to the ERC20, which is the one on Ethereum. Yeah, so up to now, I think I'll be passing the time over to Brian, which will start covering about scalability of blockchains. Afterwards, he will go on to talk about decentralized finance, and then we will finish off the workshop with an introduction to NFTs and to explore a bit more about NFTs on the Tezos ecosystem. Brian, you want to share your screen?
Yeah, just give me a moment. Firstly, any other questions for everybody? You can see on my screen, right? It's fine, right? Hello.
Yeah, I can see your screen. Yeah,
so it's fine. Okay. First thing, I think we maybe we just take a short like 3 to 4 or 4 minutes of Q&A for like the first half of the part, so that the people here can actually like ask some of the questions or answer some of the questions that was just said. Yeah. So I think Sean, I think David actually said, could you explain in detail what exactly is the POS consensus?
Sorry, again?
So one of the questions was from David. So he said that could you explain in detail what exactly is the POS consensus?
So the proof of stake consensus, you can think about it as there are a few variations of proof of stake consensus, but I think fundamentally, proof of stake consensus, you can think about it as the term called like staking, right? So people stake a proportion of rewards. They stake their token, and this represents a large pool of tokens that are being staked. And of course, some of them are basically miners, right? So when you're staking your token, you're basically you're locking your token and sort of passing it to someone who is doing a mining. It can be an institution, it can be a company who is running like multiple nodes that are sort of mining, right? And based on how much they have staked, right? That's their chance, that's their chance, right? But in percentage wise, that's also how much rewards they can possibly get from each block that is being validated, if you look at it in like the long term. And then when they sort of get selected to mine the next block, they will receive the rewards, the full rewards, and then they will distribute these full rewards to you, right, who are like the household stakers, who are not running the mining nodes. You guys are just staking your tokens. Yeah, so that's essentially what the proof of stake consensus is. How well does Tezos compete with other L1s like Cosmos and AVAX? Brian, do you want to take this?
Okay. So basically, right, you have different kind of blockchains around. You have different. So yeah, you have different blockchains around. You have AVAX, you have Cosmos, you have Polkadot, you have Solana, and each one of them do very different things, and they have very different characteristics of their whole thing. Some of them are less decentralized than the others. Some have more incentive on program than others. So for Solana is cheap to send in transactions and things like that, but it's not known for its DeFi space. So like and if you compare to other kinds of blockchain, like for AVAX is more known for its DeFi space and its ability to actually bring in a lot of liquidity through incentive programs. But if you talk about like for other like the layer ones, like for Cosmos, it's more towards like for Cosmos, it's more towards a SDK when like a kit where they actually develop SDK kit for each of the blockchains to actually bridge over from one chain to another chain. It's because if you think about for blockchain, there are its own kind of a network or the system where you cannot, there is no interoperability between like Ethereum or Bitcoin, or even for Tezos and Ethereum as well. So for Cosmos is trying to like do some of the things that are trying to bridge, or you like get the interoperability of the assets from one chain to another chain. And so so it's why I call it like these kind of blockchains or layer ones are different. So for us on Tezos, we are more specific, and we are more mainly focused on towards the NFT space. So a lot of NFT participants actually come on board to our space is because of the triple transactions and things like that, and that's how we grow our own ecosystem. So each of the chains have their own kind of ecosystem and kind of communities that they attract. Yeah, so to answer your questions on that, yeah, so there's no like a best chain or things like that, I would say. Yeah. Okay, if that is the case, any other question? If not, I think I can move on to scalability part. So basically, scalability part would be more towards like so if you realize about what Sean has spoken on Bitcoin and some of the issues with other some of the like the basic on the concepts of other chains, like the proof of stake chains and things like that. So like the biggest issue in all blockchains will be actually on the scalability part, which is actually like the part that if a user base actually grows, can the protocol actually handle this growth of users to not make it jam or so-called congested. So if we're going to speak on that, we can actually speak on like the very first example, which is actually on Bitcoin. So so for if you read on the history of Bitcoin, it started in the late about 2009, and it already has been here for almost more than 12 or 13 years. And if you realize most of the news is like it's not the fastest. I mean, it's quite a very because this is the first ever on the blockchain. It's actually one of the slowest one. It's is around, and like things like there's a lot of issues of congestion on the Bitcoin protocol and things like that. So which means that you need to wait for a long time in order to send your transactions from on the Bitcoin protocol. And this actually this whole issue, right, this whole scalability issue it has, right, is that it led to a lot of problems in 2018 when where Bitcoin actually went through like a fork war. So as Sean had mentioned, like in the previous slides, what a fork war, or like a hard fork will be like a branch out from the main branch. It means that if Bitcoin actually goes through a hard fork, it means that there will be a new currency. And some of these new currencies are not tied to the original part of Bitcoin. So you have they have this kind of fork wars that came with it, from Litecoin to Bitcoin Cash and Bitcoin SB, and it destroyed like a lot of because when you are forced to fork out of the system, or Bitcoin forks into another coin, like the original protocol will not agree with all these other newer forks of the protocol as well. So you get a lot of people trying to go away from the original protocol, or people trying to stay in the original protocol as well. So this was the main issue of the whole history of all the for blockchains for about the last 5 years. And it's because because of this whole scalability issue, like at the start, for why this fork wars happened was that because of the long congestions of timing for the Bitcoin protocol to process transactions from one address to the other. They had these two solution where they tried to raise up the block size limit, but by using that, it actually give a lot of issues, like for normal users to actually run on their software in their own homes. And so that was the first solution that they tried to fix. And so they went on to another solution, and that was to actually to shorten the time that you need to create a new block, because a new block contains your transaction. So if you could technically reduce like the time to take for one new block to go through, it should so-called fix like the issue of congested transaction being trying to approve on. And but the problem with this, it needs to have a confirmation period to confirm this how valid all these new blocks is. And in this short time, you can actually create a lot of blocks in this short time, and then you realize that there's going to be a lot of problems. So far that's just for Bitcoin. If we talk about like for other proof of stake for blockchains like Ethereum and the rest of them, there are layer ones, there are this thing called layer 1 and layer 2 solutions. So most of the time, what they mean by all this this layer 1 and layer 2 will be like they won't want to actually, like for layer 1, it actually affects the whole consensus of protocol. So like for example, one of the most common one that you always hear about as a layer 1 change, it will be from Ethereum is still considered a proof of work state. A proof of work consensus, and they are trying to move on to a proof of stake consensus. And you can actually call that a layer 1 solution, where it's actually called ETH 2.0. And some of it are like some of the other examples are like Ethereum or Ethereum sharding, or Polkadot for parallel chains as one example. And also so that's actually for layer 1, where you actually affect the entire or the original the entire protocol itself. For layer 2, you do not affect the entire protocol, where you don't change the base or the underlying baseline of the protocol, where you actually, you are trying to scale out like the issues of congestions and things like that. So a lot of these things, for example, it could be things like ZK roll ups. So those are one example on Ethereum as well. They are actually the layer 2 solutions to this kind of problems where you want to actually scale out like the transaction speeds and things like that without affecting the entire consensus mechanism itself. Yeah, so some of these are actually like examples are the state channels and Bitcoin, the Lightning network, which is actually a payment rail kind of a system where it helps to send multiple transactions in one big transactions for the Bitcoin protocol. So this is just like an illustration of what it looks like, where you have you have your layer 1, which actually is the baseline of the whole thing, which if you want to really change all of the protocols, you will need to hard forks or soft forks or things like that. If the committee do not agree with you or what they actually want to do, and for layer 2, it's actually like a existing kind of it's a solution that sits on top of this baseline layer 1. Yeah. So for Tezos, for us, we actually had this thing called the ZK snaps. So it's a bit more like where you actually we are trying to improve our payment rails and most of the chains as well. So it's actually what I just spoke on the layer 2 and layer 1 solutions. So I guess you can read a bit more towards that, but it's more like just a example of this kind of thing where for payment of a channel is more for Bitcoin, and there's actually the Ethereum plasma, which it helps to actually set out for one chain that actually it branches off to multiple child chains in order to actually improve the scalability of the whole chain itself. So speaking of which, I will end like the slides on scalability, and actually I'll go on to the ecosystem of Tezos itself. In general, it could be in Tezos, it can be on or other kinds of blockchain. So maybe I can just go through like some of the exchanges where you can actually buy and sell all your crypto, and these are some of our wallets that we have on Tezos. So we have a Temple and the KuCoin wallet, which is actually very similar to MetaMask, where it holds all your coins or your fungible tokens, as what Sean said in his previous slides, and non-fungible tokens, which is the digital art of NFT. And some of these are on us. Aggregators that usually a blockchain will use. So then I go onto one part of some applications that we really have on Tezos itself. This is quite common in rest of the other chains as well, in Solana or in Ethereum, where we actually have this thing called Decentralized Finance. So basically, what this whole thing means is that you can actually create applications on the blockchain itself to replicate banks, to replicate the use cases of banks, to if you want to mint for tokens or dollars or stable coins, you can actually do that as well. So these are some parts of so this is these are some of the building blocks that you can actually create. Like you have wrap assets or and also decentralized exchanges, which I won't go through this whole thing because I believe I'll be doing it on Friday. So this is just for one example of a DEX that you can actually swap and farm and and pool your all your tokens and things like that. So yeah, this is just for example. Okay, then so for us, we on Tezos South, we are more towards we are primarily more focused towards NFT marketplace. So we have one of our biggest marketplace is actually object.com. So it's actually a marketplace that has a bit more advanced functions of than OpenSea. You have like have options to actually sell or buy your NFT, and a bit more complex functions of NFT marketplace there. So examples of it, like what you can actually sell on these marketplaces are, you know, like digital art, or like or you know, or memes or GIF or things like that. So there are files that you can actually create, or if you already have a file that, you know, like a wave file that is like a animated NFT, you can actually mint this NFT and actually sell it on the marketplace itself. And some of the use cases are like collectibles and gaming. So for us on Tezos itself, we do have partnerships with Ubisoft and Red Bull as well. So they actually do all their, like a lot of their collectibles and things like that on the Tezos marketplace. And yeah, think so that's then the rest of the examples there are still being used in other kinds of chains as well, like, you know, AR and VR and tickets as well. So those are still use cases for NFTs. But yeah, so that's the part for the NFT marketplace. So yeah, this is one of the marketplace as well, called He Can Know Art. So it's where you can just create your own NFT and sell it to other people if they want to pick your art. Yeah, this is one of the other collection of what we actually what one of the more expensive or popular NFTs around. So it's about 20. I think that's about 2,000 tests, which is about 6,000 if I'm not wrong. Yeah. So there are some of the other marketplaces here as well, so which you can actually explore on yourself. So this is actually our ecosystem, where you know, like it will look like in some of the coins as well, where, you know, you have your tools, which are usually your MetaMask, or, you know, your front end and your back end that, you know, you will try to link in to form an application. And then you actually have your DeFi applications on inside your ecosystem as well. Your DEXs, your stable coins, your, you know, your where or your protocols that can loan and borrow and loan coins is around. And of course you have the NFT marketplaces and many other applications that we use. And for us, we do work with some of, like, you know, like that's why I've spoken for Red Bull or Ubisoft, and some of our entities are spread across on the globe as well. So this would look very similar to a bit similar to the Ethereum Foundation as well, where they also have entities here and there and things like that. So most of the community in this space, or most of the blockchain itself, will actually be on Discord or GitHub and Telegram as well. Yeah, so some of these are part of that. And of course, we also have a blockchain explorer, which is similar to your Etherscan, where you actually see transactions, like, and addresses and the blocks, you know, like who is trying to send coins around and things like that. Yeah. Okay. And this is actually our developer hub or developer portal, where I mean, this is our developer resources, where you can actually find some of your support lah, like you know, how to get started on Tezos, or how to code smart contracts and things like that. So some of these are actually quite useful on the startup. So like as what I have spoken, this is like the entire ecosystem, where it will look very similar to other chains as well, where, you know, you have the token holders, which are usually the investors. You have the validators, which is as what as they call it, a staker, which are the people that are trying to verify or validate transactions that is happening on the blockchain. Of course, you also have your community there, which are actually like can be in terms of creators or artists or developers. And then we also have projects and other, you know, and most of the things I actually have mentioned. And so like I would think that this is what it would like the overview would look like for a normal chain or a crypto coin as well. So then the next point will be how to make sense of this whole space, or how to get involved. I would say that I guess what is Web 3.0 as what like is famously called in some of the in this year only. I think this is a very new term by I'm not sure by most of the most of the institutions and things like that, banks and institutions, they always talk about this. So basically, what is Web 3.0? So if you want to look at the history, Web 1 was actually like during the dot-com bubble, where like the first ever iteration of the internet actually happened. You had your on your protocols, you had your HTTP, and most of all your database on the protocols. So those are actually like the very start of the first variation of the internet, which actually lasted for about 15 years. And then after that, right, then Web 2.0 is actually more towards what you are seeing now, where existing for existing applications or companies that are like for Facebook or Google or Microsoft as well. So those are actually those are mostly centralized for services or corporations that actually own on the service that you use, and most of the money that they actually make are based on what they actually they will get from their users, and they will try to make as much money as they can. It's because they are like more like a company, and they have to run it like for a profit. Yeah. And now we are actually part of like the beginning of Web 3.0, which is actually more towards like like you can see here like it's more towards have different chains around. You have Ethereum, you have Tezos, you have Solana, you have different coins that makes up have different ecosystems around. You have different coins, and you have different communities that have different coins as well. So it gives you like that kind of activity that each person in this new space, or anybody in this new internet, can actually participate in and do whatever they want with the entire coin. So what is Web 3.0 is that or perhaps like the most important thing will be actually the whole part of decentralization, where most of your databases, your apps are hosted on Facebook or Amazon. If they crash, you actually you can't actually use on their services, or if they are hacked, right? They most of your identity or your information might get leaked out, which is why you have this single entity that controls the entire market, which is quite bad. It's because if one incident like a hack happen, right, it's kind of very damaging to your own for your own privacy as well. And so in this case, right, it means that all these applications that you see here, all these kinds of blockchains around that you see here, are based on peer-to-peer networks that you don't need a third-party entity anymore to transact. So, and then you don't need banks in a way, I would say, is because if as a blockchain itself, you can actually transact coins around, and it means that you don't need to operate with that kind of trust that the bank has. So that gives it a trustless and permissionless kind of value to the whole to this whole new space. And and of course it also helps like a lot more people to actually connect, because you are saying that anybody across on the world can actually use coins and transfer in and out. So you are saying like if you're saying like a low wage worker who works in America, who wants to actually send he or she wants to send cash back to back to the Philippines or things like that. He or she can actually send for stable coins without transacting with the bank already as well. So that's actually a plus point. And of course, like the last part will be like will be more towards like a new kind of internet where it's more like, how you say, you don't need any more on the centralized entities or nodes anymore, where we are still trying to get to that phase of a new phase of the internet. Yeah. So like what I just said, why it's so important in Web3 is this whole thing with open, trustless, and permissionless networks that anybody can actually participate in, and without the use of a governing body. And and so like more like to end off this whole thing, it will be like, if you go on Twitter, there's always this like this kind of philosophy by most people who support on blockchains or crypto in general, that is like it gives a lot of people, or you yourself as a user, like the property rights to own on your own coins. It also gives you the property rights to own your own digital art for creators and collectors as well. And like and no one can actually like own like this whole kind of coins around, in one sense that there is no centralization of this whole thing where you are at the mercy of a centralized entity. So just for example, if Mark Zuckerberg actually creates a Zuckerberg coin or things like that, if Facebook close down and things like that, this entire coin will be gone, or considered useless, I guess. Yeah. So so that's the whole part of what I want, what we actually we wanted to talk about web 3.0 and what are blockchains in general. I mean there's a lot more to talk in terms of in the applications and some of like of the other things, but I'll leave it for the next workshop to actually talk about like decentralized finance and what you can actually do with decentralized finance through this whole space. So it's a very interesting talk where you yourself are the bank already. Yeah. So so to end it all, like what we actually do at Tezos is that we actually help we actually give out grants to interested or people or developers to actually develop tools on the space, or or even as for workshops or educational things. So you can actually approach us for internships or hackathons or grants, and you can contact me and Sean. This is our information, and I'd like to thank all of you for actually going through this whole deck with us. And if you have any other questions, we can go for a Q&A now if you want. So thank you. Just give me a moment.
I think David asked one question, is whether Tezos is EVM compatible. No, Tezos is not EVM compatible, and as a developer, I wish it was. But there are a few reasons why it isn't. And this goes back to, I think, very like fundamental questions as to the purpose of Tezos when they started building it, right? And I believe that when it started, they wanted to be something that was different out there with other blockchains. And like there were a lot of research actually, and a lot of papers published that went into the idea of using Nicholson as the lowest level language in order to build Tezos language. And so basically I don't have a perfect answer as to why it isn't. It is built in such a way because I'm sure it offers certain security advantage over EVM compatible chains. But at the same time, you are also right that, rather that there's a con to it as well, that the fact that it is not EVM compatible, it is hard to get developers on board, right? Because Ethereum is dominating, and it being an EVM compatible chain, we see a lot of other L1s that are coming up and also being EVM compatible. And that's one of like the key pointers in order to draw developers over. Like even Solana is coming out with like Neon Labs, right? Which is trying to allow people to publish EVM compatible smart contracts. And you never know, maybe in the future, such an application or such an L2 might exist on Tezos that allow EVM compatibility to exist. Yeah, so in short, for David, I don't have the answer as to why not. I believe it's very fundamental in like the theory of why we decide on Mickelson in order for us to achieve like formal verification, an extra layer of security or sort, stuff like that. Yeah. Yeah, is there any other questions? You guys can type in the chat or just unmute yourself. As a developer in Tezos, what is your job scope like? Okay, so I'm the only developer at TZ APAC. So it's a bit different. Like Brian mentioned, right, that at TZ APAC, we are an adoption entity. So under our company, we actually have an umbrella of projects. They can be startup projects that are very small, like maybe 2 to 3 people writing into Tezos to say, hey, I want to build this certain application on Tezos. How can I get started? And that is where we arrange like calls with them to walk through with them their technical architecture, to look at whether fundamentally that is something that is achievable on Tezos blockchain. So this is where I come in, like sort of to give advice on the application of what they're trying to build. Some can be larger companies who are trying to adopt blockchain, right? Like institutions trying to adopt blockchain. And then Tezos might be one of their options. So we arrange a technical call with them to run through what can Tezos offer them, and also sort of like show to them why we are better as a blockchain for them to select us. So for me, when there are certain side projects, then of course I'll be doing development work. If not, most of the time, I'm trying to keep myself updated with news on Tezos, especially since our upgrades and protocols in the development scene are moving pretty fast. So it's important for me to understand what can Tezos offer to different companies and their use cases, and to make sure that I also give them like the right resources, point them in the right resources, provide them with the right documentations as and when these different projects require help with. Yeah. Does tokenization of the internet really give the owners of these tokens a piece of Web3 debt, considering that ultimately it is the miners?
I think I answered on that.
Okay.
Yeah. So basically, right, you have your chains around, which is like your layer 1 chains. They can be Ethereum or Tezos or Solana or AVAX. And those, like, it really depends on when at the start, they are usually funded by the venture capitalists, and if their tokens are if they are circulating tokens, or their total supply is already distributed enough, then in a way you can actually say that those tokens are more distributed to the community or things like that. And I mean of course, at the very start you will still have big kind of stakeholders, or what is it called, whales, that holds a huge chunk of the tokens. But in terms of some of the chains around, some actually are it depends on what kind of distribution they already have faced. So that is how you can actually see that those that are more like distributed, or distributed in the terms of how they give out on the tokens, are in a way more decentralized as well. It's because you come pump and dump as hard as you can. Yeah.
I was actually asking more towards of the general. I think you mentioned on Web3 is owned by the token owners. So in that case, these token owners, while they own these tokens, they are not owners of the mines and the nodes. So technically, if let's say all these people who own the mines and the nodes come together and decide that, okay, they will change this entirely, there is nothing that the token owners can do to prevent that from happening. Is that right? Or just take Solana as an example. I think it's quite common to know that Solana is comparatively very centralized compared to some of the other cryptos, and it's mainly owned by their VCs and people who got in on pre-sales. So if let's say I mean, I think it's not news that Solana has been down the past few days, but not for long, because they are able to, in a way, reset the network pretty efficiently, precisely because of the fact that it's centralized, and you don't need to coordinate that many node owners to essentially restart the network. So there's this if let's say you build a Web3 dApp on Solana, does this really mean that the owners of these tokens are owning a piece of the internet?
In your case, it will be more towards the validators and the nodes where they control the entire, transactions and to verify transactions on the blockchain itself. So like what Sean has said, like the blockchain trilemma, which there are three things. So security, decentralization, and also scalability. So it's like a trade-off where the more decentralized are, the less scalable you are. So you're probably slower than a lot of chains, but you are more like, how you say, like you're more resistant to some of the proof of work or proof of stake attacks. Then in terms of scalability kind of issues, where Solana, I would think, has a high amount of transaction speed and things like that, but it's not very decentralized and not very, because of that, it could also lead to issues with it being not very secure as well. So that will actually fall under like that kind of trilemma, that there's actually a trade-off between what each chain is trying to do. Yeah.
All right, thanks for the answer.
Okay, to explain Matthew's question on, do you mind elaborating on shard chains and how does it work? So basically, we have identified that like scalability is a huge point of issue that people can foresee in the future, right? It's not hard to see that as more users come on board, more transactions would mean more congested networks. And sharding is one of the method where you partition the network. So basically, remember the Byzantine video that we were showing, and we were saying that every node in the world will store a similar copy of the blockchain, just so that everyone is on the same page, right? So you can think of sharding as basically just breaking down this huge history that is stored on the blockchain, right, into pieces, in a way where a group of nodes, right, will be sort of storing a certain information and validating it, and then another group of people will be storing another set of information and validating it. So which also means that you can imagine that to have consensus for a particular transaction, right, you are achieving consensus within a smaller group as compared to like the millions of nodes that you have out there. Yeah, so think of it as like just partitioning like the database into different subsectors, and all you need are just subsections to agree among themselves. Then you sort of achieve like validation. Yeah, but of course, I would foresee straight away that there are certain issues to this, because that would mean that it is sort of less decentralized, right? That a certain particular information is now living on lesser nodes out there compared to the original many nodes. Yeah, so I think sharding is just one of the options that many blockchains have looked into. Another way that people are looking at tackling scalability is also like L2s, right? Like ZK rollups and stuff. So what you're doing in L2s, you're basically packaging, for example, in L1, right? Let's say Ethereum, you want to do like 1,000 transactions, and all these 1,000 transactions are individual. For L2, what you're basically doing is that you bring it up to an L2 and you do this 1,000 transactions on the L2. You package this 1,000 transactions, you sort of hash them into a smaller byte size, a smaller memory size. And now this simple hash or simple data represents this 1,000 transactions. Then from L2, you go back and validate using your L1, which is Ethereum, let's say, or any other blockchain, and you validate that transaction, which represents 1,000 transactions. Yeah, so that sort of like L2 expansion allows more transactions to be packed and then not congest your layer 1 traffic that much. Yeah. Okay, so I don't see any more questions coming in. You guys don't have to ask technical questions. Like if you want to know like which coin is going to pump, you can ask Brian. No, just kidding. But is there a particular roadmap direction that Tezos is looking towards? I understand that Tezos has sales market share in NFT, but it's lacking in the DeFi space. Yes. So you are actually correct. Like even personal thoughts, I think we also feel that Tezos is lacking behind in terms of DeFi space. And the reason like for us to boom in NFT is because like we pride ourselves in being energy efficient. And as you see institutions onboarding the NFT hype, right? It's not easy for them to just say, oh, I'm gonna launch NFT on Ethereum, because you can imagine they might get backlash, right? Launching on Ethereum will mean, oh, like you're burning a lot of trees, you're not being eco-friendly by choosing Ethereum. So they might get a lot of backlash from the community. And that's why the narrative of Tezos sits in so well with institutions onboarding NFTs. That's why like over the past year, we start to get a lot of traction. And also because it's cheaper, you can imagine a small-time artist who's trying to explore the NFT space. It's easier for him to come on board Tezos and pay a few cents to get his artwork on the blockchain, compared to Ethereum, where you probably pay like $10, $20, or sometimes even up to $100 to get your artwork on the blockchain. In terms of our roadmap, I believe in the Asia region, like, or rather for TZ APAC as an adoption entity, we are expanding our developer ecosystem. So I think that's the most important thing. Like I think all blockchains out there, the most important thing is to have developers in your ecosystem. And that is why you see like AVAX or Solana when they were still starting out, like there are so much incentive being given out to developers to welcome them onto the platform, right? That's one way for them to attract. Another way, of course, is like you mentioned just now, being EVM compatible is really important to pull those sticky developers from Ethereum over to your blockchain. And that's one thing that Tezos probably struggles with a little. But at the same time, as a developer, I would say that the community in Tezos is very tightly knitted. In a way, people who are developing Tezos, like they are very close to each other, or rather it's a very close-knitted community because of the fact that we are not really that large. And you can find answers from each other instead of like just going on to Overflow and like copy-pasting codes and stuff like that. But yes, I think we are working towards like expanding our developer ecosystem. At least that's what I know in TZ APAC region, within Singapore, of course. And that is also why we are reaching out to a lot of schools. We are running workshops with MOE, other universities as well, to kind of introduce blockchain to them. The idea is to get them intrigued about blockchain, what the whole Web3 space is about. And of course, then we will present Tezos as one of the blockchains out there that is here actively in the APAC region, for you to reach out to us if you ever want to start a project or if you ever want to develop on us. Does Tezos work like a DAO in terms of the way the governance system operate? Yes, you can think about it that way. From my understanding of like the voting protocol, it works very much like a DAO. Besides the risk of being hacked, what are the risks of staking coins? Why are the rates for stable coins so high? Brian, you want to take this question?
What do you mean by rates of stablecoin? Interest rates, deposit rates?
Yeah, interest rates.
So
Anchor protocol.
that's under the terror on the network. Okay. I guess it depends on I believe what the anchor on the protocol was trying to achieve was to give you high yield, but they would so-called go through a feedback loop where they actually sell or buy on the Luna. It's why in terms of if I think it's anchor is ANC, but not wrong. Yeah, when you deposited, you get a certain amount of yield. So a lot of people are trying to out farm, trying to yield farm on their way to max min it. But in the process, where if you get a mass liquidation, I believe in May of last year, we got like a big kind of a correction where where the UST was actually, the UST is actually the stable coin in the Terra protocol. It was actually depegged by 20%. So if I'm not wrong, like it's like a feedback loop, but where if it's stable enough, it will not depeg so huge. But I mean, if the interest rate is very high and things like it's like that, you must actually think of what on the protocol is trying to do. If they are buying back on, like their governance token, which is the Luna coin, or not the Luna coin itself. So some of these use are like you really have to read through what they are trying to do. It's not because the interest rate is really that high, because of the risk that if the system or the liquidity is very unstable, all these kind of coins will either get depegged or things like that. Yeah, it's a bit complicated, because each of the stable coin have their own way that they buy back, or they buy a token to pay back on the use and things like that. Yeah. If that answers for all your questions, which is a bit hard to, yeah. Okay, let's see. Does it have its own stable coin? Yes, I believe on the stable coin on Tezos, it's more like the USDT or USDC. If I'm not wrong, it's Colibri stablecoin. So or as Sean has pasted on the link. So basically it must be backed by actual dollars or USD. So which means that the actual there is actually controlled by another entity, where the underlying risk is actually the entity itself that holds your dollars, and you need to trust it enough to not run away with the dollars or the or the peg because it's pegged to the USD, and you need to actually hold the back assets of USD. Yeah. So that's actually different than your algorithmic on the stable coins. So algorithmic on the stable coins around in all the chains, you will know is UST, magic internet money, as what as they call it, MIM and things like that. Yeah. And yeah, so there are two types of stable coins. Yeah. Well, one is institutionally backed by reserves of US dollars, and the other one is algorithmic for stable coins, where they use some kind of feedback loop or a system to peg it to a stable rate of the dollar. Yeah. Yeah. Any questions like crypto collateral? What do you mean? Example, on perhaps, I don't think we call them. If you mean by loans and protocol, where like in terms of our other protocols like Aave, when you need to. Oh, okay. Oh, okay. Yeah. Oops. Yeah. Yeah. Okay. Any other questions?
I have one more question actually. It's about the governance part again. I think the governance part is good, because it allows for people to vote in terms of what direction as a whole they think is best. But then wouldn't that do you think that would also bring about its problems? Like if you look at democracies and parliaments, you'll see that sometimes because of the voting system, the project, the things that needs to be done for the project gets delayed because of the voting and all that process that's taken place. Do you think that will affect Tesla's scalability and development in that sense?
I think for large scale projects, like the upgrading of an entire blockchain protocol itself, definitely it's going to take a while. And I think, yes, having this voting protocol is a system put in place that probably lasts 20 days in order for a protocol to go through, right? But at the same time, this structured protocol, it's moving definitely way faster than how Ethereum promised Ethereum 2.0, right? Like almost for half a year already, and then it's just delaying and delaying because of how hard it is actually to sort of do a fork on other typical blockchains. Like, I think that's a lot of considerations that goes into upgrading other kinds of blockchain that are not on-chain governance. And yes, there might be some sort of delay, but it's sort of like a structured process on Tezos. But yet on other blockchains, it's very flexible and very variable, right? But the thing is that on other blockchains, each time a protocol comes up, it's a new fork, whether it's a soft fork or a hard fork, and you sort of have to migrate your community over to the new fork. And you can imagine, like in the decentralized space, it's not easy to always convince people that one is better than the other, right? Even though sometimes it may be obvious, you still have people on the other chain, and that is where you start to have segregated community. So I think the good thing about Tezos is that we are always on the same page. I mean, it's more like, not that we're always on the same page, even if you're not on the same page or you're against the protocol, it sort of went through a very structured way of voting. And when it's approved, I'm sure there are certain considerations that are put into it. So I think in the past few protocol upgrades to Tezos, right, we sort of start to see how the narrative is shifting in the blockchain scene. For example, NFTs coming up, right? We start to try and increase our transactions per speed. We try and lower our block timings just so that more massive adoption can come into place. And also with like GameFi coming up, right? It needs to be important that more transactions can go through at the same time, at a shorter time. And then in like the recent Hangzhou upgrade, we also start to make it more easy to do inter-contract calls between one another, just because of the complex interaction that might come up when all the metaverse things start building, all the GameFi stuff starts moving. And yeah, so I think in general, to answer your question, yes, it might be slow, but maybe when we compare it relative to like other blockchains, it might not seem that slow. Like a 20-day approval period from voting all the way to the upgrade itself might not be something that is very slow. Yeah.
Actually, on that,
Yeah.
right? Sorry. Yeah, on that, who is actually deciding what is being sent to be voted for? Like how do you come up with those how do I say, like project ideas and things like that? Like who is the one that's giving all that to vote?
Also, I believe it's a lot of different developer teams across. Some are official entities of like Tezos, like you have the Nomadic Labs. And basically, I think there's a way for them to, sorry, I don't really know like the exact details as well, because I don't, it's not like I submitted a protocol for amendment before, but I believe there's sort of like a way for them to submit the idea, right? Like the things that they want to fix, the bugs that they want to do, and they submit all each as an individual proposal. And then just now the bakers that we are talking about, right? Depending on how much they hold, how much XTZ they hold, that's sort of also equal to their voting rights, right? So this can be delegated voting rights, or it can be voting rights solely by the baker themselves. And basically when you're staking your XTZ, right, you can choose from a bunch of bakers, and you can sort of, by choosing them as your baker, you're giving them your voting rights. Yeah, so then with the voting rights, they go through the whole process. To the details of like where they submit the protocols, how they submit, I don't really have answers to that. But in general, the process is somewhat that way.
Yeah, if you're interested, I just paste a link there. You can actually see how the whole submission actually works. Yeah, it's a pretty long process. I think a 5-step kind of a period where they need to go through like 4 periods to get on the protocol upgrades to work. Yeah, or to pass through.
All right, thanks for the info.
Okay. Yeah, I don't think there are any more questions. Maybe you can just leave it open for another few seconds. If there's no questions, then maybe we can end the session. Is there a point of contact from SMU's side?
Yes, Wei Li, yes. Hi Wei Li. Do you have any
Wei Li.
more questions?
Hi, Brian. Yeah, nothing from my side. Thanks for having the talk, by the way. It's quite interesting to hear about the blockchain stuff, especially from like the Tezos side. But yeah, right now there isn't really anything from our side. If anything, I think if anyone's interested, feel free to visit the SMU Telegram. And if anyone has the link for it, let me send the link tree for SMU blockchain. So if you guys haven't joined in on any of the channels that we have, you can feel free to go ahead. But yeah, thank you so much for the talk, and that's it for me.
Okay. Thank you. Oh yeah, and you know, and what I think I never see that at the start of the slide. Yeah, all these are not what do you call it? This is not for my financial advice, and you know, don't take my word for any financial advice things. Yeah, things like that. Yeah. Okay. Thanks everybody. Yeah. Have a nice day. Okay.
Okay, bye guys. Thanks for having us.
Bye bye. Thank you.